So should have copied this equation from the front side, and that is our factored form. We want to turn it into standard form. And so this is what we've been practicing on our daily questions. We see that there's the two sets of parentheses, and so order of operations would tell us to do what's inside the parentheses. They're not like terms, so we can't. But that's why the FOIL comes in. So we're going to go ahead and take that first term in the first parentheses, distribute it to both terms in the last. Take the second term in the first parentheses and do the same thing. Distribute it, meaning multiply it, by both terms in the last set of parentheses. So doing those 4 lines will create 4 new terms by multiplying. Of course, x times x gives you x squared. And then you're going to take your outside numbers, multiplying together to give you the next term. Your inside numbers will give you the third term, and multiplying and these are the only two that are actually just numbers. So you can do the multiplication, which times 1, just pretty easy multiplication. So now we turned these two binomials into one long polynomial, meaning many terms, and we can combine it down to a trinomial, down to 3 terms, because we notice that the 2 middle ones, those are our like terms. So if we take those 2 together, should be able to combine them into 1, whatever your numbers are. And then we're going to do a little bit more distributing. We've got our a value out in front. It needs to get multiplied by what's in parentheses, so we're going to multiply it by all 3 terms. So our a value of a very small negative number times your x squared. Just put those right next to each other. The next one, we're going to multiply by that middle number to give us this guy right here. And then finally, the only 2 that are just plain numbers is going to end up over here. Make sure you've got an x squared behind your first term, an x behind your second term, and of course, just plain number on the third term. Once you've done that, then it is in standard form. So you can go ahead and transfer that equation over to the box there. And you're done with the 4th step. 5th step says we're going to go to Desmos.com and type in that equation. Once you type it in, hopefully it shows you a graph of your equation, a parabola that should look something like that, starting really close to the point 0, 0, only a little bit above it because our projectile was a little bit above the ground when it was sitting in the catapult. And then, of course, your vertex, the middle point of the projectile path, and then the landing point, the x-intercept. If your parabola is going the wrong way, if it's a right side up U-shape, that probably means you missed the negative sign. We have a negative slope, so make sure that's negative. And then it also might be too far up or down. So if your parabola is too far up or too low like this, there's a few things we can do to correct that. So the first thing that we could do is just try typing in the factored form instead of the standard form. Remember, we started with the factored form over here, so you can try typing that in. If, when you type that in, and I would type it in a separate box, so you've got both of these equations, both this guy and this one typed into Desmos. And if they totally overlap over each other, that means that you did this middle part right, because these should be the exact same they're the same equation. All we did was we changed their form. So if they overlap, then we'll have to go back even a little bit further. If they don't overlap, you can just use the factored form instead of the standard form. If they do overlap, we have to go back a little bit further, and what's probably going on here is that your A value is a little bit off. So in Desmos, you can get rid of that number. Do make sure that it's a negative number, and you can just start kind of trying different numbers out. Let's see here. And of course, that A value affects the slope of your parabola. And so if your slope was too steep, like this, meaning that it would maybe not even cross your x-axis at all, but it would definitely cross it somewhere way below 0. So if it's too steep, that means we need to make that A value even smaller to make our slope flatter. So you can try making it smaller than you had it before. Or if our parabola is too flat, if it crosses the x-axis way too high and it goes way further out here than your actual distance of your parabola, or then of your projectile path, then we know we're going to have to make that slope steeper. So we're going to have to increase the value. It shouldn't be even close to 1, so it shouldn't be that high. But do try, it's a little trial and error, kind of shifting around different numbers for the A value until you kind of get it keyed in to where it looks like that highlighted line right there. Once you've got it close to modeling the actual height, so there's our height, average height, as well as the distance, there's your average distance right there, then do transfer it over to your worksheet. I've chosen units of about 25, so every line here is 25, got 50, and then it'd be 75 and 100, all the way up to 150 here. So that works since my distance was 125. If your distance was less than that, you might want to use 10 or 20 units. So every line here maybe goes up by 10. So you'd have like 10, 20, 30, 40, 50, 60. That is, if your distance was less than 60, then by 10s would be a more fitting unit. Whatever units you choose, go ahead and make sure you're labeled them. Make sure you label what they are, probably inches. You might use centimeter as well. Give yourself your X and Y. Label those X and Y axes. And let's see here, we also want to label what we're talking about. The x-axis is our distance, the y-axis is our height. And then we also want to label what those points are along the way. We've got our y-intercept, which is our starting point, our x-intercept is the center point. Our vertex is the center point, and their x-intercept is the ending point. And finally, very last thing, make sure and list the coordinates of those points. And once you got it looking like that, then you're done. We've constructed a catapult. We took data from the launches of the catapult. We took that data, plugged them into equations, and with those equations, we modeled the projectile path of our catapults. And you're done.